This next problem is asking us to find the necessary equations of equilibrium for the object below. So if this object is in equilibrium, that means that the sum of the torque equals 0 and the sum of the forces equals 0. So that's the sum of the forces in the x direction and the sum of the forces in the y direction. So if this is in equilibrium, the sum of the forces in the y direction equals 0. So that means all of our up forces equal all of our down forces. For this problem, we have two up forces, that's Fy and Ry. And so we get Fy plus Ry equals our down force Fg. And then we'll sum our forces in the x direction. For this case, we have only our x equal to Fx because the sum of the forces in the x direction equals 0. We're going to sum these torques now, write our sum of the torque equation, net torque equation about the axis 0 down here. Now, the R forces, Rx and Ry, are not causing any torque if my axis of rotation is at point 0 because there is no lever arm. And so the sum of the torque will be equal to my torque due to gravity, my torque due to Fy, and my torque due to Fx. Using your right-hand rule, you can see that the torque due to gravity will cause a clockwise rotation, which will be negative torque. The torque due to force Y causes a counterclockwise rotation, or positive torque, and the torque due to X causes a negative rotation. From here, it's just as simple as writing our forces and our lever arms. So the sum of the torques equals 0. So torque due to gravity is the force of gravity, perpendicular times the radius. In this case, the radius is going to be L over 2, plus our torque force Y, perpendicular, times our radius, our lever arm, which is L, minus our X, perpendicular, times our radius, which is going to be L as well. Now comes the tricky part when we actually have to talk about what our angles are and what are these perpendicular forces. So I'm going to erase this real quick. When I look at this, there's a couple of ways I can think about this. I can drop in a perpendicular line here, and I can say that this angle is going to be equal to theta, just by geometry. Or I could look at this and draw a slightly different triangle. For this, I'm just going to go ahead and call that angle theta. And so I'm looking for my perpendicular force of gravity, which is this adjacent side. So Fg perpendicular is actually Fg cosine theta. And then I'm going to pull this L over 2 out front, just so that it doesn't get wrapped into my theta term. Plus my Fy perpendicular, when I look at this, I might drop in my perpendicular here. No, let's put it here. So if this comes out like this, this angle theta here is going to be the same as this angle theta here, because we have two parallel lines and a line that's intersecting them. So it's going to be this angle up here that's theta. Okay, so when I look at that, now my F perpendicular is going to be my adjacent side for my Y. So this is going to be, I'm going to pull my L out front. Fy cosine theta minus, I'm going to pull my L out front, Fx, and for my x, I look at this perpendicular piece of this angle, this vector, and that's a sine function, sine theta equals 0. Now all we need to do is solve for whatever we need to solve for. We could pull things out of this equation if we needed to as well.